Hey guys, so in this example, we're asked to sketch the graph of the quadratic function and identify the vertex and x-intercepts. So we're given x squared minus 7. Now, while this is given in standard form, I do want to refer to vertex form to talk about this because it's important that one, you understand the different transformations that can occur with the parent function, and two, it's important that you consider just different possibilities of how you can think about a quadratic function. So if you can get it to vertex form, you can easily see what transformations occurred to the parent function x squared. So think about the parent function x squared, you know, whenever you square your x, you get the y value for that point. So when x is 0, our y value is 0 because 0 squared is 0. When x is 1, 1 squared is 1, so our y value is 1. When x is 2, 2 squared is 4, so our y value would be 4. When x is 3, 3 squared is 9, and so on. And then we can go back the other way. Negative 1 squared is 1. Negative 2 squared is 4, and so on. So if we consider just the parent function and then think about what happened to that parent function, that's going to be probably the simplest way to think about this function in particular. So your a value, remember, determines whether or not there's a vertical stretch or a vertical compression. So if your a value is a whole number bigger than 1, it doesn't have to be a whole number, but a number bigger than 1, then there is a vertical stretch. So your graph is going to appear narrower because your function is increasing at a faster rate. If your a value is a fraction, so it's between 0 and 1, the absolute value of your a is between 0 and 1, then there is a vertical stretch and your graph is going to appear wider because it is going up at a slower rate. Your h value is 1, the x value of your vertex, and also can be considered as a horizontal translation. So it's going to move your graph left or right. If your h, if you see minus, so if you see minus 3, that's actually going to move your graph to the right 3 units. So it appears to be opposite of what we would normally think. If you see a plus sign inside those parentheses, so if you see plus 4, that would actually move your graph left 4 units. So kind of think opposite with that because we're pulling out the h value that we're actually subtracting from x. Okay, notice here with our k value, it's a plus sign, so that means it's going to keep the exact same sign that you see. So k deals with a vertical translation, so up or down. So if you see plus 2, that means your graph moved up 2 units. If you see minus 4, that means your graph moved down 4 units, and so on. So if you take a look at our function, we know that our a value is 1, and we know that our h value is 0 because we're not subtracting anything from x and then squaring it. It's just x. And then our k value would be minus 7. So which direction did our graph go? Since it's k and it's negative, so it's minus 7, we know our graph went down 7 units. So that parent function that we talked about at the beginning, where you just square your x's to get your y values, it's going to be that exact same shape, just move down 7 units. So we can take what's normally at 0, 0, move that down 7 units. Okay. We can take, normally we're at, from that 0, 0, we go over 1, up 1. So that's what I'm going to do. I'm going to go over 1, up 1. I'm going to do this the best I can using the computer. And then over 2, up 4. Over 3, up 9. Let's see, that'd be here. And then it's going to be mirrored on the other side. Over 1, up 1. Over 2, up 4. Over 3, up 9. All right, and then let me connect those dots. Okay, so just remember I am using the computer to do this, so this is kind of as best I could do. So your paper version should be much cleaner. So we have our graph and we're asked to find the vertex, so we can see that our vertex would be 0, 7. And again, we also know that because our h value was 0, we're not subtracting anything, and our k value was negative 7. Sorry about that. 0, negative 7. Okay, and then for our x-intercepts, we can see it's falling between 2 and 3. We want to have the best either approximation or exact value if we can. So to find that, here our y value is 0, so our function value is 0. So we can replace f of x, which is standing for our output, and we can put 0 because our y value is 0. And we're solving x squared minus 7. Okay, so anytime you're solving for the x-intercepts, you can set your function equal to 0 and solve. Sometimes you're able to just take the square root, sometimes you'll have to use factoring, and then sometimes you may have to use the quadratic formula. So if we solve this, I'm just going to flip this around, x squared minus 7 equals 0. We can add 7 to both sides, and we have x squared equals 7. So the inverse of squaring something would be to take the square root. Okay, and then anytime we take the square root of x squared, we just consider the principal root, which would be the positive root, so just x. We don't say plus or minus x. And then on the right side, we do need to consider both roots. So that would be plus or minus the square root of 7. Okay, so that makes our x-intercepts, we've got one at square root of 7, 0, and then the other is at the negative square root of 7, 0. And using the square roots, that gives us the exact value. We didn't truncate any decimals, cut them off short. This is the exact value.